Hi guys, good afternoon. So in the last session we started with the static route, but first let's cover about simple network management protocol, SNMP. Now, why is this protocol used? So we can simply say it is used for monitoring the network. In simple words, if we say this protocol is used to monitor the correct. Now, in general, what happens that admin has to go and manually check the devices. Admin has to go and manually check the devices. Like what kind of things you are going to check in the device? What are you going to check in the device? As a network admin, every day may not like there may not be problems every day, but it doesn't mean you just have to go sit and relax, right? You can check for bandwidth consumption, CPU uses, right? That will be your day-to-day job. That you go and check out your devices, how they are performing. Okay. So that is our day-to-day task. Now, until or unless you check a device, a router is not going to speak up of itself like, my CPU is going to be 100% and all. Correct? So for that reason, we have this protocol. So SNMP uses an architecture of, manager and agent. Okay, so I can say like it uses manager agent architecture. Okay, so that means we do have an SNMP manager and we do have SNMP agent. These are the things. If we talk about SNMP agent, so this is a program that is installed in all the devices, your routers, switches, firewall, cameras, everything has SNMP installed. Clear? That is the agent. Responsibility of this agent is what? That it's going to get some information from the device. It's going to get some information from the device. An agent simply, if you want to understand, you can understand like it's kind of a task manager for your system or for your device. It's kind of a task manager that is going to continuously monitor, CPU, memory, whatever the disk usage, internet speed. Okay. Like generally in case of PC, let's say I need to check that, okay, why my system is not working properly, whether or not my CPU is 100%. So where do I check? Task manager. So this is a program that is going to hold that information. So similar kind of stuff your SNMP agent is. That is going to continuously and regularly monitor your network devices performance. Clear? And this agent is not going to again say anything about itself. Like task manager is not going to give you a pop-up that your CPU uses are 100%. You have to go and open the task manager and check. Then only you'll come to know. Same way, this agent is not directly going to give up information. What do you have to do? You need a manager to ask for that information. So what is a manager? Manager is a program that is installed on a central system in a network, on one system. And that particular system, we also call it as a, what do we call it? The system where this is SNMP manager is installed, network management station. The system where your manager is installed, that system will be kind of known as network management station, NMS. Because from that particular system, you are capable of monitoring your entire network and all the devices. And clear? Now, both the things are a program. This is installed on a central system and agent is installed on all client devices. Or instead of saying client, I'll say all network devices. Clear? Right? Now, whenever you have to see any information, whenever you want to look at any information, so let's say, for example, this is my SNMP manager. And this is my SNMP manager. Okay. And you have some of the managed devices. Maybe you have a router, switches, and okay. So right now I'm just making random symbol. Just say these are your devices. Okay. That you want to monitor. So what will happen? This SNMP manager, it is going to do what? It is going to send a message. Your SNMP manager is going to send a message. So let's keep it a bit like this. It's going to send a message, and this particular message will be known as what? SNMP get request. This is the message your manager is going to send to the agent. Okay. These are all what? These are all managed devices. These are all what? Managed devices. Okay. So kind of you can say here also we have an agent installed. Here also we have an agent installed. And here also we have an agent installed. So manager will send a SNMP GET request. Okay. And then whatever the information your manager is asking, with that particular information, your agent will respond to it. Okay. The agent will respond with the same information. And this particular message will be known as SNMP GET response. Manager asked for some information, agent gave that information. Let's say manager asked what is the CPU uses. Manager gave the agent gave the information. In my task manager, I go and click on the CPU. It will tell me CPU uses. I'll go and click on RAM. It will tell me RAM uses. Similar stuff. Understood? Okay. Now we are also capable of, with the help of SNMP, right? With the help of SNMP, we can configure thresholds in the devices. I can say that, okay, if my CPU usage goes beyond 30%, 50%, 70%, I should get an alert. You know how, what happens in your mobile data? Company gives you the information, you use 50%, you use 70%, 90%, something like this, right? Similar to that, we can configure thresholds. We can configure thresholds. So we can say that, okay, if my CPU usage goes beyond 60%, send me an alert that my CPU router is consuming CPU more than 60%. So that I can already, before my network goes down, I can go and take a look that what is going on in the network. Okay. Then I can say if my RAM usage goes beyond a specific level, I can say that if an interface goes down or up, I can ask that, right? So that means we can configure some threshold limits there. And what will happen when that particular threshold is met? That time, manager is not asking anything now. This time, manager will not ask anything. Manager just configured what? Threshold. Now that particular event happened in the system. So what will happen? If the event occurred, this guy will directly send a information without anything asking. And this message will be known as SNMP trap. This message will be known as SNMP trap. So this SNMP trap message will be sent whenever there is a special event in the system. That means you configure threshold, that particular threshold is met. Interface went down. interface, maybe one of the interface is down, maybe one of the interface that is not up but came up, that new device has been added to the network. So those kind of things. Is that clear? So it is going to send what? SNMP trap message with the relevant information. And then what this manager will do, how you have configured the manager might send an email to you or a SMS to you. That is based on our configuration. Clear? Now, if we talk about the port numbers, what is the port number used by SNMP? 161, 161 and 162. TCP or UDP? UDP port number 161 and 160, right? These are the port numbers used. Okay. So in what case 161 and in what case 162? 162 reply. Check. Port number 161 and 162 SNMP. Correct. Port number 161 for your general SNMP communication. That is this get request, get response. And if it is a trap message, it will use port number 162. Understood? So uses UDP, right? Correct. So you will say, whenever you're asked about port number, make a habit that you will always mention, along with the port number, you will mention whether or not TCP or UDP. Like if I say, what is the port number for HTTP? So everybody will say 80. Nobody will say port number 80 TCP. So make it a habit. Okay. Because port number 80 is also present in the UDP. You can simply say SNMP, and this is for SNMP trap. Clear? Now, let's say, for example, manager asks for some information. How your agent will come to know that what is the information being asked? How your agent will come to know what the manager is asking? Get request, but in get request, there will be something. There will not be like plain text that, okay, tell me CPU uses. Similar to like ARP. ARP doesn't say that, okay, tell me your MAC address. This is our understanding, layman language. But what exactly happens? How does it understand? Options. No options. How? No. You studied SNMP, right? Strange. You had 2 days, right? You could have checked Saturday and Sunday. If I said I will be discussing, then at least you should check, or else you are just completely dependent. Whatever I say is the universal truth. Hmm? How? In CCNA, it was there, right? SNMP? Yes. How many of you think it was there? There is something called as OID. What is it? Object identifier, full form. But what it is? What is the OID? Object. OID, object identifier, a large sequence of numbers separated by a dot. How an OID looks like? Something like this. This is OID. A large sequence of numbers separated by a dot. So with the help of these OIDs, your agent will understand. With the help of OIDs, your agent will understand that what the manager is asking. Okay. This is an example. So if you want to define object identifier, there is a large sequence of numbers separated with a dot. This is what a OID is. And looking at the OID, it will understand that what kind of information it is. Understood? Um, Then your agent collects a lot of information from the device. From the managed device, your agent collects a lots of information. Where does it store it? MIB, man in black. Then what is MIB? So MIB, management information base. Management information base that holds a lot of files related to the information. Okay, so whatever the information your agent is collecting, that information will be stored in the MIB. Okay. All right. Now, bit of practical for this. Online people, any doubts so far?
No, sir.
Okay.
Sir, OID from manager to agent, right?
Yeah. Any information exchange in the SNMP has an OID. Looks like servers and down. I need to start the hacker machine also because I'll show you the OIDs. Let's go. So this router here, this will be working as a SNMP agent. I need to wipe out these devices. And this my base PC, I will be using it as a manager. Okay. Visible. So here IP address as of now, if I check, so it is 193. Okay. So hacker machine IP right now 19, and the management IP 1.94. This is manager IP, which is my base PC. And on this router also, I'll accept an IP address from the, you can say DHCP only. Okay. How do you configure SNMP in the router? How do you configure SNMP? Okay, I'll explain. So as of now, this is going to work as our SNMP AD. Hostname, SNMP, interface, gig 0/0, and I'll say IP address, DHCP, and I'll say load checkpoint. I'll allow it to take an IP address. So you can see I have taken the IP address as 104. The IP address is 104. We can verify, do through IP interface brief, and we can see here IP address is 104. So this is 104, right? Okay. Now I'm going to configure SNMP here. So first of all, if we talk about SNMP versions, SNMP has 3 versions. SNMP version 1, SNMP version 2C, and latest version SNMP version 3, which is secure. Okay. And your SNMP communicates based on community strings. Based on community strings. Now, what are these community strings? These are kind of passwords. These are kind of passwords. Okay. So there are two types of community string. Okay. Number one, read-only community string. And number two, yes, it is read write. Okay. Read-only community string, as the name suggests, it allows only checking the parameters. Like you can check the information. While read-write community string, it allows to write the parameters like setting up thresholds and all. Okay. So if we talk about your read-only community string, okay. So here the default read-only community string is public. This is the default read-only community string. While the default read-write community string is private. These are actual passwords, not the words public and private. These are the actual kind of passwords. Clear? Okay. So we'll set up this community string here. Okay. How do you set the community? And SNMP configuration is very easy. How do you configure it? You say SNMP server community. Now just type in the community string. And what is the community string? Let's say public. And what kind of community string it is? Is it read only or read write? So this will, let's say, give me access of read only. Then this is your SNMP configured here. One line. Okay. This is clear. Okay. Now let's start the manager. Okay, note it down first. Step by step. Community strings noted. The comment. This is the comment. Ah, you can set it anything. It doesn't have to be always public only, but it has to be same on your agent as well as the manager. It has to be same. Clear? Whatever you configure here, the same has to be configured on the manager also. Like I said, this is kind of a password. Clear? So if you want to give read write access, you will just say using the public also you can give the read write access. I can say RW. So this will give what? Read write access. Clear? No, no, no. Public is the password. You can type anything. You can type your name also. Totally fine. Like I said, this is the password. You can set anything here. It was asking us for word. It was not saying that you have to write the public only. Understood? Okay. Note it. Now let's configure the manager. So I'm using the PRTG network monitor, right, as a manager. We'll go to the devices. And here earlier I had already added this device, right? But it was with a different IP. So I'll remove it. I'll right click and I'll say delete. I'll say delete. Okay. Right. Now I want to add this device. So you see here by default it is checking, so many devices like, local probing it is showing, network discovery it is showing, right? Then in the network discovery, different types of devices it is checking. So if I want to do network discovery, I'll just right click here and I'll say I want to add a device. And before adding a device, I need to show you that the community string also will cancel. I'll go to the management. Not the management, settings. And in the settings, if I scroll down, credential for Windows system, credential for Linux, okay, VMware, and you see credential for SNMP devices. And right now the version being used is version 2C. What is the community string set here? What is the SNMP port number set? 161. Understood? Okay. Then we will just use, we have already set this community string in the router, correct? So everything is fine. Now we can go and add the device. So in the network discovery, I'll right click and I'll say add a device. Device name. So whatever the name you want to give, I'll just name it same as the NMP agent. It is using an IPv4 address and the IP of that device is 172.16.1.104. Router's IP address is what? 104, right? So I have given the IP address. Then I can say that, okay, which company device? So icon I can give, this is a Cisco router. So I'll use a Cisco icon here. This is the one. And then rest of everything, auto discovery. So I'll say default auto discovery will be used. Okay. And then I'll say, okay. Now see, it will try to communicate with the router. You can see auto discovery is in progress. Now wait for it. So it will show you everything related to the router like CPU usage, RAM usage, interfaces, all those things. You see, already discovered that 4 interfaces are there, which is gigabit 0/0, 0/1, 0/2, 0/3. Okay. Wait for it. Right now, just only 4%. And on the router also, I can go and check, right? We might be able to see something if I say debug IP pathway. So there might be some sort of communication going on. See, destination port number 160, right? So some communication is going on. Yes. Correct. And you can see the protocol being used is already ping tested. Ping has been tested 26 milliseconds. Uptime, so router has been up for 12 minutes, 45 seconds. Okay. Interface gig 0/0, 0/1 has been tested. System health, like that. This will keep on checking. Understood? Hmm? Correct. By default, you can take the PC IP network or public IP. They have to be in the network, right? Or else if they are in a different network, you need routing. That's it. Because no DHCP server or anything is connected to it. Why not connected? This is management cloud. Management cloud means it is using my base network. It's using my base network. Okay. You see here, everything is being tracked. Now let's say right now CPU load is not coming up. I can just click here and it will start showing me in some time. It will start showing me CPU load also. Network is gone. Why? No, these type of things will be used. Now you can see this is the ping status, interface status, CPU health, okay, memory health, everything being checked. Okay, and in, like I said, in some time it will show you CPU load also already. What is the load? 13%. If I want, I can go with the live data and it will show me in the type of graph. Okay, and I can go with the overview. SNMP basically works first thing on the auto discovery. It will automatically, if you see, it will locally probe all the devices. So I haven't configured this thing like check my internet connectivity, check my gateway connectivity, check my DNS connectivity. SNMP will try to discover the devices automatically. If the devices are in network and protocol is running, then SNMP will try to discover it automatically. That's why it is asking for credentials, right? Windows credential, Linux credential, because it will try to test those things automatically. Okay, so benefit is you don't have to add the devices manually also. Manager will automatically discover the devices if the credentials are okay. Understood? Online people clear?
Yes, sir. Sir, this
Mhm.
is a SNMP manager. This one.
And you can see any doubt.
Sir, this is SNMP manager, right?
Correct. It
Okay.
is a network monitoring tool which
Okay.
is also working as a SNMP manager, but also other services are there. Okay.
Okay, fine. Okay.
And you can see right now I have some values. Correct. If I click here and if I scroll down, do you see I have an upper warning limit? I have a lower warning limit. So I can say if my CPU usage fall below 5% or if my CPU usage goes beyond 90%, 60%, 80%, I should get an alert. So those things I can configure from.
Here is we can configure the threshold limit, right?
Yes, yes, exactly. Okay. So how do you want the limits? Like enable alerting based on limit. Okay. So based on limit, it will alert. So there are a lot of things we can do. Then how the reports alarm should be there. Okay. So you can see here all those things. This is clear. Now about OIDs. So one of the OID you can see here itself. Let's say if I go to settings and if I scroll down, see here. This is what an OID looks like. Okay, and there is a used number of OIDs, and those if you want to see, then we need to attack on the router. Okay, on the two keywords. These are the OIDs. Okay, and based on the OIDs, information you will see. Now, right now we are trying with all the OIDs to get all the possible information. So with the manager, if other devices are connected, so their IP addresses, their names, those all information. Like if I scroll a little bit down, so here you can see what is this? Router's operating system. This is the version. Okay, this is my gateway's IP address. On which interface the IP is? Recursive. Okay. Then if I scroll bit up, you see this is my router's IP address. Okay, so different OIDs give different information. Now see here. These are also OIDs. Okay, that what is the network here? Automatically discovered other IP addresses. See, 56, 1.1, 1.94, 1.104, 1.193. So like this, we can gather the information. But overall idea is to show you OIDs, so you can see the OIDs. Clear? SNMP is clear now? Okay. Okay. So this is our topology for the routing. Let me wipe out all the notes. Okay. This is clear. Let's see it. Okay, you can find it in your drive. Now, yesterday we were going with the recursive static route. Okay. So recursive static route, we saw that, okay, what is going on here? We use the network ID subnet mask and next stop address. And whenever we are using next stop, what happens? Tell me something about recursive static route. Number one, we have a disadvantage. We have a disadvantage. What is the disadvantage here? Hmm? Checks the routing table twice, which that condition particularly is known as recursive lookup. Okay. So here we have an issue. What is the issue? Recursive lookup is a disadvantage. This is the disadvantage. Now, if we talk about recursive lookup, what is recursive lookup? What is recursive lookup? Router checks the routing table twice. Simple. Okay. So in this type of static route, the router checks the routing table twice for every single packet. For every single packet. The first lookup. The first lookup will happen for the next hop. And the second lookup will happen for the exit interface. Now the question is why? Because take a look here. Let me just quickly configure these routers. This is it. Interface loopback 1, IP address 10111. Loopback 2, 20. Loopback 3, 30. Loopback 4, 40. Loopback 5, 50. Done. Exclamation also correct. This is for coming. Exclamation mark is for coming. Whenever sometimes happens that you don't want to execute something, maybe you want to have a note in your configuration, so you can have it. Okay. For example, like I might be interested in having a note, something like I might be saying that whatever the commands I'm configuring here, so to let's say log string like for example. Now this is not a command. Normally, if I will type, what will happen? My router will give me an error. So I can use it. Then I can say configure host name, configure interface. I can have a note in my configuration. So that will help me better understand my configuration, right? And second thing, it will not be executed. So it's not going to cause any errors. Okay, see here. Right now I'll copy it and this won't cause any error. get it. R2. So I can paste that configuration here. Now you can see this line is not generating any error form, right? Done. Now if I check, first of all, I check end-to-end connectivity. That means from 12.1, I should be able to ping 12.2. So I'll say do ping. Will I be able to ping? Yes. What happened? I'm not able to ping. You can take a look at the configuration.
That
Mhm. Yes. Take a look at the configuration. Tell me if anything is wrong.
sir, R2 interface J0/0.
Wrong interface configuration. Okay. Good. So I'll say default interface is E0/2. Done. Now let's try the communication. See, I have the communication. If I check my routing table, do show IP route static. Do I have any route? No. So if I try to communicate with the 10.1.1.1, will I be able to communicate? No. Okay. Let's test. Do ping 10.1.1.1. Now why I'm not able to communicate?
There is no route.
There is no route present. That means the packet is unroutable. The packet is unrouted. Okay. Another question. How many packets when I try to ping? How many packets my router sent? 5. Okay. So note this thing down. Router by default sends. Okay, or let's say I'll say number of packets. So if it is a unicast, router will send 5. If it is a broadcast, router will send 5. If it's a multicast, router will send 1. Clear? And in an ICMP packet, how much data router sends? 100 bytes. Okay. So what I'll do, I'll just go and configure a route. So I'll say IP route. I'll say 10.1.1.0. Subnet mask. Then next hop address. What will be my next hop? 12.2. Let me do one thing. 12. Correct. Okay. So now if I check in my routing table, I should have a route. I do have a route. That means I should be able to communicate, right? So if I say do thing 10.1.1.1, I'm able to communicate. Okay. But if I check my routing table, right? If I say do to IP route. Now understand the recursive lookup here. When I say ping 10.1.1.1 in my router. So first thing my router checks is how do I reach this guy? Do I have any route in my routing table? So router will check. Yes, I have a route. I have a route in my routing table that I can reach 10.1.1.0 network and I can reach via 12.2. But the thing is that 12.2 itself is IP. And if I need to forward the traffic, I need to know through which interface I should send the traffic, right? So router will say, okay, I know that I can reach via here. But how do I reach this IP? Again, router will check that, okay, how do I reach 12.2? So 12.0, I can reach via the interface, reach 0.6. So for forwarding one packet, router check the routing table twice. Router check the routing table twice. Now imagine router forwarding 1 million packets. How many times router will check the routing table? 2 million times, right? And imagine the amount of CPU required to do that, right? Heavy CPU uses. Okay. So there are 2 times lookup. So we can say that if the router has to forward 1 million packet, router will check the routing table 2 million times. Yeah. Okay. Now there is an advantage also here. Here for recursive route, we have an advantage. What is it? For recursive, we have an advantage. What is the advantage? Hmm? Where? How IP is mapped with the interface? Mhm. That is recursive lookup you're talking about. That is a disadvantage. I'm asking advantage. Here I'm asking advantage. Hmm. Okay, take it as a task. Tomorrow you will tell me. Advantage of recursive. But I think I'll have to tell it in some time when I'll discuss fully specified. There's no point in giving it as a task. So I'll tell. The advantage of recursive static route. Okay, first thing first. One more route I'll. Okay. Let's say I have to ping to 21.1.1. How do I give a route? Hmm? IP route. Is it 21.1.1? 0. Okay. So, right. One is self. Last session, I clearly explained this thing. If I check my routing table right now, I have a route. I'll have the communication. This is the first time communication I'm having with 2111, right? I'll have the communication or not. 80%. No, my question is I'll have the communication or not. Communication will be there. How many of you agree? 1, 2, everybody, right? Communication will be there. How many packets will drop? Because remember, one thing you guys remember, one thing to remember, router does not hold the packet. Unlike PC, router does not hold the packet, router will drop it. So how many packets will get dropped? Hmm? Okay, some people saying 0. I'll ask you why. But first, let me ask other people. I don't know. You tell me.
Route is present in the routing table. I think
Yes.
packet will send forward.
But with this IP, I'm having first time communication. Remember, for communication, we do need MAC address. How many packets will drop? 2 packets. 1, 1. Nobody else? 1, 0. 0, 2, 1, 1, 1, 2, 2, 1, 1, 2, 1. Online people?
Destination network is reachable 0.
0. Okay. I think some other discussion is going on. Okay. Yes, Harini.
1, sir.
1. Anybody else would like to say something?
0, sir.
1. Okay. Some people are saying 0. Why? Which interface? I mean, it will not look twice. It will look twice, but it shows that it is already connected to the 0 by 0. Okay. What about the MAC address? When you ping an IP for the first time, don't you need the MAC address for this IP? So if I did not communicate with this IP, do I have the MAC address in my app cache? No. So if app is going, that means my ICMP will be at the hold. Hold means router does not hold. Router will do what? Drop it. So now tell me. Yeah, why? Some people said 0, some said 1, 2. Nobody said 3. I can say 3. I think 3, but I don't know why. Things doesn't work like this, right? Yes, online people, those who are saying 0, can you tell me why? Balakumar was saying 0.
No, sir.
So now tell me how many packets will drop. Still you think 0? I don't know. My understanding is our cache already has 12.2 market. So what? That is for 12.2, not for 21.1. I'm pinging 20.1. So tell me how many. What do you think? Answer is three. Okay. I should have said 5. Uh, answer is 0. Answer is 0. There will be no packet drop. Why there will be no packet drop? Look back. The reason is this. The reason is this. How? Understand how? Because whenever you are using a recursive static route, so in the route, what you are using next stop address. So when you are using a next stop address, your router never generates ARP for the destination. ARP is only generated for the next stop, which is already done. ARP is only generated for the next stop, and that is already done. So you can see here that when I try to ping 10, first of all, I ping with 12.2. Success. I got the MAC address for 12.2. Then after, we gave a route for 10.110, right? And then I tried to ping. There was no packet drop. Why? Because I mentioned here the next stop. So the ARP got generated for the next stop, and the cache, the MAC address was already there in the cache. There is no ARP generated. Same thing is there in this case. Same next stop. So I'll ping, and nothing will happen. No packet drop. So here, what you need to understand is take a note. When recursive static route is used, the router never generates an ARP for the destination. The ARP is only generated for next stop. Okay. Now behind that next stop, I might be having thousands of network. Behind that next stop, I might be having thousands of network, right? But how many ARP my router will generate? Only one. How many entries will be there in my ARP cache? Only one. Because only one next stop I have given. If I will give multiple next stop, then it will take multiple of. Understood? This is what happens in our real cases also. Our home routers. Okay, understand this thing. This is my home router. My home router is connected to my ISP router. And then with the help of ISP, I'm connecting with the entire world. This is the case. Now our home routers, they are not very high-end routers. Correct? They are not very high-end routers. And this is my gateway, let's say. So in my gateway, now understand, every day you visit thousands of sites. You don't know, but you visit thousands of sites. How? Sublinks. Okay. Now you are using, family is using, cameras are there, smart TVs are there, you're watching Netflix, XYZ things, right? You are surfing websites. So number of websites you're visiting, WhatsApp and all those things, right? So for every website, there is no, like you can say there is no ARP generated. If you take a look, right now, let's say this is my PC. Okay. Right now, let's say this is my PC. And if I will check here, right? If I say ARP-A, so you will see that I have ARP for my local network and multicast and broadcast addresses. That's it. There is no anything, nothing there like 8.8.8.8. I think last one time I have discussed this thing that my PC will never generate a ARP for the destination. It will generate for the next hop. Same way, if you have given next hop in your route, your router will never generate a ARP for the destination. It will only generate for next hop. Is that clear? You want to see this? We can clearly see this. I can say do show up. Show up. Okay. Now here I have another question. Okay. There is one command, show up. Okay. There is one more command, show IPR. What is the difference? Don't say the IP keyword. Why two separate commands for the same thing? Hmm? Mind blowing, huh? Why two commands for the same thing? Hmm? Programming mistake. No, this is not programming mistake. Intentional. And this is not a mistake. So why? And have you noticed, in router, let's say you are defining static route, how do you start your command? IP. Why do you start with IP? Why do you have to tell the router that, okay, this is IP route? Why can you say this is just a route? Because, huh? Router is a device that supports IP, IPX, AppleTalk, these kind of protocols. So you mentioned that, okay, right now what I'm doing the configuration that is for IP. So why these two commands? Show ARP. This command will show you ARP cache for all the protocols, IP, IPX, AppleTalk, all the protocols. But when I say show IP ARP, this will show me ARP cache only for IP protocol. Understood? Yeah. Now, right now you can see I have a entry port 12.2. How do I clear this ARP cache? Basic, fundamental I'm asking. How do I clear the ARP cache of a router? What about a PC? ARP-D. What about router?
Clear IP
Clear IP.
or clear IP ARPA.
Clear IP ARP. Okay, let me try this. Second. Clear IP ARP. Hmm? Cache. There is no such thing. Hmm? IP address. But I need to clear entire ARP cache. Hmm? I need to clear the entire ARP cache. How do I clear it?
Interface shutdown and
That's check. Hmm? I thought there would be a command. Oh, server off and on. Server is down. Comment. Until or unless you see here CR, you cannot. If I'll say clear IP app and enter, sorry, this is show IP app. It will say incomplete comment. You were saying something. That was right. Forgot. Command is clear of cache. Okay. If I hit enter, and now if I check show IPR, doesn't work. This command is there, but most of the time this command doesn't work. Command is there, but most of the times this command doesn't work. Now, one solution is we already had the last result off and on, right? But rather than device off and on, we can just shut down the interface and bring it on. Okay, the command is clear IPR, but we can do what? We can say that interface down and up. We just go to the global configuration mode, interface leave 0/0, shut down, not shut down. Okay. Same. Now check do show R, which interface leave 0/0 only, right? Please, please. I think it will already do an R. See, router is dynamically learning this particular MAC address. Okay. You can see the age, that how long it has been there for 0 minutes. Okay. So what we can do about this? Right. Like a permanent configuration. Hmm. Dot one. Okay, this is happening because see why this thing is happening, because I have this route. So because of the route, what is going on that as soon as my router is trying to add this route in the routing table, it is testing the reachability. And to check the reachability, it will have a backend communication. And due to that, the app is happening. Okay. Okay. So right now, because you can see any other entry I will not be having, right? If you take a look, show IP route. So you can see for 10 and 20, I'll not be having an entry. Okay. If I say ping 10,111, I'm able to ping without any drop. I'm able to, but still I don't have any such entry in my app cache for 10 and 20. Why? Because the app is not getting generated for 10 and 20. Yeah. And sometimes what we can do, you want your router not to generate broadcast. You want your router not to generate a broadcast message, not to send app request. So what we can do, we can make a static app entry in router. We can configure a static app entry. That means I can manually configure the entry. So my router doesn't have to go and check by itself. Okay. How do you do that? So just go to the global configuration mode. Okay. And you can say app, then IP address 192.168.12.2. Then after MAC address, let's say whatever the MAC address. Okay. Then after you will say alpha. This is the type of MAC right now we are using. Advanced Research Project Agency. Okay. This is the encapsulation we are using. So alpha you have to say. Then if you want to bind it with some interface, you can say the interface also, let's say big zeros also. Okay. So right now this interface thing is not supported. So without interface also you can, and the entry will be there in your, okay. You can check root to. So okay. All right. Okay, right now you see the app entry is not there. Now I can show you that the app is getting generated for debug IP app. Debug app and something. Okay, simply I'll say debug IP packet. Okay, now I'll try to ping 10,111. So you'll see that the app is getting generated for next stop. This is on the layer 3 IP. One more time. But you can see again app entry, we can check that happened on the for 12 hours. Okay, clear? Interface you can only use when you're bridging an IP. Right now, no bridging. Means you are bridging an IP with the interface. That's all. And that entry was already there in my app cache. That is the reason. Okay. Out. This is clear. So when recursive out static route is used, the router never generates an app for the destination. App is generated only for the next stop. Okay. So behind my next stop, there can be thousands of route. Okay, thousands of network, but my app entry will remain only one. This will save memory also. This will save memory also. Then second type of route. Correct. Why? Because of app. Earlier I was not having an app entry. You can see here. I was not having app entry for my next stop, which is 12.2. So when I ping, it tried to find out that, okay, what is the MAC address of the 12.2? So for that reason, one packet drop. And you can see after that, I got an entry for 12.2. Clear? So recursive static route is clear. Next one is directly connected. Okay, directly connected static route. Now, what is this directly connected static route? Tell me. What is the directly connected static route? We will have exit interface because in the recursive static route, we were having a problem. When we give next stop, so router tries to check the second time that, okay, how to reach that next stop, through which interface, right? So rather than, eventually router will end up finding an interface only. So why don't we give the interface directly so that router doesn't have to check the interface, correct? So here what we do is, we say IP route then you'll say your network ID, then you'll give the subnet mask, and you're going to give exit interface. Okay. Now, when you say like this, your recursive lookup problem is solved. Your recursive lookup issue is solved. Why? Because you don't have to check the routing table twice. So let's try this thing. If I check do show IP routes started, so I can see for 10 and 20, I have a recursive static route. Now what I'll do is, I'll say IP route 3111 255.255.255.0 and exit interfaces x0/0. On R1, we have only one interface, which is my exit interface x0/0. So I'll hit enter. What happened? Let's see. Hmm? How can I solve this problem? Hmm? 254. Okay. Where? Which part? Huh? Last one. 254. Right?
No, 255.
255.
Five.
So either keep it 255, or if you want to keep it 0, you have to say here 0. Okay, both are correct. Okay. Now if I check my routing table, what it says. So that means this is a directly connected route. Yes or no? But what the code says? Static route. Now this is static route or directly connected route? Directly connected static route. So that means AD value for this route. According to directly connected, it should be. According to static, it should be. So 0.5. what will be the AD value here? Okay, how many people are saying 0? 1. No. 1. 1. 1. 1. Everybody says 1. Somebody says 0 also. Hmm? Hmm? Okay, online people, 1 or 0?
0.
0.
Sir,
Okay,
yes is mentioned, no? So one static route.
but also it is mentioned here, right? Hmm?
Yes.
How do I check? Let's see if you remember the comment 2 days back. What is the comment? How do I check? Don't scroll the types. We can check, right? Although the answer is 1. Okay. What it says, distance is 1. Because we statically configured this route. We statically configured this route. So the distance is 1. Just use a heading. Okay. So this is my directly connected static route, and within my route, you see, I don't have a next stop. I directly have my exit interface. I have my exit interface. So will I have communication right now? Yes. So if I say do ping 30111, my one packet failed, and I got the communication. Okay. Let's add one more route, IP route. Okay. So if I check my routing table, this is my routing table. This is also a directly connected static route. Now if I ping 40.1.1.1, how many packets will drop? How many packets will drop? Why? App will be generated for the destination. Here there is no next stop. If there is next stop, then app is generated for the next stop only. But if there is no next stop, that means app will be generated for destination. Why app is getting generated for the destination? Number one, next stop is not present. Number two, because your router considers it is directly connected. That means it is within my network only. And in a local network, app will be generated. Right? So here one packet will drop. So again, one packet will drop and we will have the communication. So here the benefit is what? What is the benefit of this type of routing? The recursive lookup, there is no recursive lookup first of all. Okay. So that means we can say here that with this type of static route, the recursive lookup issue is solved. Correct. But there is a disadvantage also. Hmm? Number one, app. The app is getting generated for when directly connected static route is used. The app is generated for every single destination network. For every single destination network. That means for every destination app will be generated. That means if you are visiting 1,000 websites, how many app entries will be there? 1,000. Right? So that will consume a lot of memory. That will consume a lot of memory. Okay, this is one disadvantage. Another one. Another one is proxy app. Okay, so this type of routing depends on proxy app. This depends on proxy. This is depending on proxy. Okay, does a loopback interface have MAC address? You guys tell me, I don't know. Does a loopback interface have MAC address or not? Hmm? Hmm? If no MAC address, how does it communicate? Does it have a MAC address? No. Hmm? Yes or no? How many people are saying no? Only 3, 4, 5. Okay. How many are saying yes? None of the above. Hmm? A loopback interface does not have MAC address. Why? Because it's a logical interface. MAC address is assigned to a physical interface. Okay, so for communication, your loopback interface uses the physical interface MAC address. So, mhm, obviously, answer is correct. Okay. Okay. So loopback interface is not having a MAC address, but even though if it was a physical network also, proxy app dependence would be there in case of directly connected static. Okay. Now, tell me, proxy app is by default enabled or disabled? Hmm? How many are saying enabled? 1, 2, 3, 4, 5. How many are saying disabled? Only. What is this? Hmm. Disabled? If it is disabled, that means router should not give the MAC address. You should not have the communication. When I tried to ping 30 and 40, was I having communication or not? I was having communication. Those were directly connected static routes. That means I got the MAC address, right? Then who gave me the MAC address? See here. If you take a look, I have the same MAC address for 12.2, same for 30 and 40. Same MAC address, right? That means this guy is giving me the MAC address. That means proxy address. Proxy ARP is enabled. On a Cisco router, proxy ARP is enabled by default. Okay. So note
Sir,
it down.
this MAC address is MAC address or device MAC address, huh?
This is interface MAC address.
Okay, okay.
Okay, Z0 by 0 interface of R2. That means when this guy is sending an ARP, R1 is sending an ARP on this side. So this interface is giving the MAC address. Okay, R2 is giving the MAC address of this interface. Okay. Note it down. On Cisco routers, interfaces, proxy ARP is disabled, oh sorry, enabled by default. How do I check whether it's enabled or not enabled? Running config, there is an invisible command. If you check do show run, so this is the interface characteristic and you will not find it. On any interface, you cannot see any command related to proxy, right? So how do I check? Command is show IP interface and the interface name. And this will tell you clearly that the proxy app is enabled. Okay. Command is show IP interface name. Okay, so many mechanisms are there, like split horizon is enabled or not enabled. These all kind of things, like interface characteristics, you can check using this command. Okay. So how do you check it? You say to check if proxy ARP is enabled or disabled. You can say show IP interface and then interface name. Now let's say it is enabled by default. The proxy app is enabled by default. What if I want to disable it? No IP proxy app, right? And this is the interface level characteristic, so you have to go on the interface. Okay. To disable proxy ARP, on an interface, we can just interface name, and you can say no IP. And if you want to enable it, this is the command. Then no communication. Why did we disable? Why did we disable? What is the point of disabling? For security reasons, in an organization, proxy ARP is always disabled. Okay. In organizations, we don't keep proxy ARP anywhere. We keep it disabled. Why? Because otherwise, what will happen? Let's say I'll connect a router to your organization and I'll do a directly connected static route. I don't need to know next hop IP address also. Right? Now what? Your router will act as a proxy and your router will start routing the traffic. And then using your network, I can attack on some other company. Problem, right? Understood? Okay, now see here. If I check do show R, so you can see I have a ARP entry for 30 and 40 and see the magic. Now if I say clear R, will not be there. Okay. Sometimes it will get clear, sometimes you can do anything. Okay. Now interface gig 0/0 shutdown, no shutdown. Do show up. You don't have app entries. I'll go on the R2, enable configuration terminal interface gig 0/0, no IP, proxy out. Disabled. We can verify. Okay. So I can say, sorry. To show IP interface gig 0/0. So you can see proxy app is disabled. Now, if I try, first of all, to show IP route static. So you can see I do have directly connected routes. And if I say ping, (30.111), no communication. And you can capture the packets. Okay. Again, I'll try. Check. Who has 30.111? Just app is going on. Who has 30.111? Okay. But there is no reply to the app. Clear? Same way if I try for 40, there is nobody going to reply to this also. See, who has 40? Nobody's replying. Understood? Why? Because the proxy app is disabled. Now, just go here. Interface gig 0/0 IP proxy. Okay. Verify. Proxy app is enabled. Earlier, nobody was responding to these app messages. Now, this is 30. Take a look. Who has 30? And R2 responded that 30 is at this packet. And then ICMP request and response. Same thing for 40. Who has 40? 40 is at this. Same mathematics. Clear? So this is your directly connected and recursive static route. Now remaining fully specified and all we will go over tomorrow. Clear? Online people, any doubt so far?
No, sir.
Okay. All right, guys, then I'll see you tomorrow. Have a good day.